Hello again, this is Mr. Wynn with part 2 of the Algebra 2 first 9 weeks DCA review. Last time I finished problem number 8, so I'm moving on to number 9. Solve the following system of equations. That is the correct format. It has x in line, y's in line, z's in line, the answer on the other side. So I'm going to make it a matrix. That's the fastest way to solve this. So I'm going to make a 3 by 4 augmented matrix. You want to label the columns, you can. This is the x column, the y column, the z column, and the answer column. I'm going to fill in the first equation. So that's going to be 8, 3, 6, 43. Second equation, negative 3, 5, 2, 32. Third equation, 5, negative 2, 5, 24. Now I'm putting in the calculator and do REF. So I'm pulling up the calculator. In the calculator, you press second matrix, right to edit. A is a 3 by 4. Fill in the numbers, 8, 3, 6, 43. Negative 3, 5, 2, 32. 5, negative 2, 5, 24. Then the second quit, second matrix, math, RREF. Second matrix, A, enter. It gives you back an equation. You have to write down what it says. That 1 goes to x. So 1x plus 0, y plus 0, z. So just a single x equals negative 1. So x equals negative 1. The second equation said a single y equals 3. So y equals 3. Then the third equation says a single z equals 7. Z equals 7. Alright, remember this is an ordered triple, so you should combine to a single point. This is negative 1, comma 3, comma 7. If you like to classify it, this would be consistent, independent. 10, very similar. We have another system of equations, but this is all out of order, so we gotta fix it. The first equation, the y is on the wrong side. I can move it to the other side by adding it to both sides. So here's the corrected equation. X plus 2y equals 12. The second equation has a z on the wrong side. I have to move it to the left side by subtracting 4z both sides. So the second equation is 3y minus 4z equals 25. And the third equation is in the correct format, x, y, z answer. So x plus 6y plus z equals 20. I'm now going to make that matrix. So I'll move it right here. Matrix again is going to be a 3 by 4 because there's 3 equations. If it helps you, again, you can label the columns. I'll call this the x column, the y column, the z column, and the answer column. First equation, it's going to be 1, 2, 0 because z is missing, equals 12. 0 because x is missing, 3 for y, negative 4 for z, equals 25. Then 1, 6, 1, 20. Type in my calculator just like last time. So I'm going to go second matrix, edit. I'm going to type over this, or you could reset your calculator to clear it. 1, 2, 0, 12. 0, 3, negative 4, 25. 1, 6, 1, 20. Second quit, second matrix, math, REF. Second matrix, A. I get this. So again, that 1, make sure you read the equation back. That 1 goes to x, so x, plain old x equals 6. Second one said a single y equals 3. And third one, a single z equals negative 4. Now be careful here. The question was not find x, y, z. The question says find the value of 3x minus y. So we got to plug that in. So 3 times 6, so that was x, minus y. That's 18 minus 3, that's 15. So be sure to answer the question. This one we had to find x, y, z, and then use it to plug in. Alright, number 11. Write the system equation needs to model the situation. At a competition involving multiple schools, one school earned 47 points with 2 first place, 3 second place, and 4 third place finishes. Another school earns that many points with that many finishes. Another school earns that many points with that many finishes. How many points is each finish worth? So this theme is going to be a school by school by school. Alright, so the first school, has an equation. So instead of like a name, instead like Andy went and bought 3 hamburgers, 3 hot dogs, and 4 drinks. It's in the first school. They had 2 first place finishes. I'll call it 2 times F. F means first place finishes. 2 times the points of for first place, plus 3 second place finishes. Second, let's do S, and then 4 third place finishes. So I'll say a T for third place. Equal to how many points? 47. Alright, so 47 points for 2 first, 3 second, and 4 third. My next equation is going to be the next school. So it's 45 points for 3 first and 5 third. So be careful here. So it's 3 first. You put 0 second if you want, or you can skip that, plus 5t. That equals 45. And the third one, third school, earned 48 points with 1 first, 7 second, and 1 third. So 1 first, or just F, 1 F, our own F, plus 7 second places, plus 1 third place, equals 48 points. And that's it. This one just says write the system. It doesn't say solve it, but you could put that in matrix form in a 3x4 matrix. Use a calculator, REF that to get how many points the first place is worth, the second place is worth, and the third place is worth. 12. Very similar. Just write the system equations needed for the situation. At a festival, Dennis bought that many hot dogs, burgers, and drinks for that much money. Mitch did the same thing, and Robert did the same thing. How much did each item cost? Again, just write the system equations. So again, it's person by person by person. So Dennis, the first guy, bought 2 hot dogs, 2 burgers, 2 drinks, and paid $13. All right, so that's my first equation. Let's see, hot dogs, burgers, drinks. Let's do H for hot dogs, so 2 times H, plus burger 2 times B for burgers, and drinks 2D. Paid $13. Next equation, Mitch was 3 hot dogs, 2 burgers, 1 drink for $12.75. So 3H plus 2B plus 1D, or just D. You can put the one that you don't have to, equals 12.75. And the last guy, Robert, 1 hot dog, 3 burgers, 2 drinks for $14. So 1 hot dog is just H, or 1H, your choice, plus 3B plus 2 drinks equals 14. Again, we're not solving, just writing the 3 equations. You could, again, put that in matrix form, do a 3x4 argument matrix, REF that to find out the individual prices, but we don't have to here. 13, another one. All right, you're going to write the system, we're not solving. The results of a recent high school swim meet stated that there are 24 people that placed, earning a combined total of 53 points. First place is worth 3 points, second place earned 2 points, third place earned 1 point. There were as many first place finishes as second and third place combined. Alright, so this one is actually like the coin problem. So let's do this. There are 24 individuals placing. Alright, so that's one equation. So I'll call F for first places, S for second places, and T for third places. So basically F is like first place people, S is for second place people, T is for third place people. So those 3 groups together should equal 24 people. So that's my people equation. Now I need a points equation. So 53 total points. Now this is where we use this. First is worth 3 points. Second is worth 2 points. Third is worth 1 point. So first is worth 3 points. This would be 3 points for every first place finisher. That's what F stands for, every first place finisher. Plus 2 points for every second place, so 2 times every second place finisher. Plus 1 point for third, so 1 for every third place finisher. That was a total of 53 points. So this is very similar to the value equation for money. So if we were talking like $53, and I'd in like F is like whatever nickels, it'd be like 0.05 F. All right, so we have my total individuals equation. I have my total finishers equation. I have my total points equation. And that last one is that one tricky one that you have to think about. Is there are as many first place finishers as second and third place finishers combined. So I'm gonna do this one on the side. All right, first place, they come in first place to second and third place. But there are just as many as the other two combined. So when you combine the other two, you have to add them. So F equals S plus T. Now realize that is not in the correct format. We want it to be in elimination form. I want the letters on the left side in the correct order, and the answer, the non-letter, the number on the right side. I have to fix that equation by moving the S and the T. I'm going to have to subtract S from both sides and T from both sides. So this is really F minus S minus T equals 0. That came from the equation in green. That will be my equation I use for this, because now all the F's are lined up, the S's are lined up, and the T's are lined up. So be careful here. Now we have a total individual equation, a point equation, and then that last one, think about it, separate the two things, and make sure you fix that equation by rearranging it in the correct format. 14, domain and range. Remember, for domain, if it's a line, it's a graph, you have to answer the question, how far left, how far right? So for this picture, it goes left all the way to -8, and it's closed. It goes right all the way to 10, because we're looking at x's, and that is open. So we could say, or, remember you see two numbers, you're going to write like this, -8, less than x, less than 10, but for the -8 it's closed. Right, so that's x is between -8 and 10, where -8 is closed. Alright, range is very similar. Range is how low to how high. The lowest this picture goes is -6, and that is on a closed point. The highest it goes is to +5. Again, that's the open point. So that's interval notation, or if you want the other way, we have -6, we have y, we have 5. Always do less than signs. And because -6 is closed, put the equal sign there. Alright, same idea for this other picture. It's the absolute value, you can tell. Domain, how far left, how far right? It goes left forever to -infinity. Again, infinity is always have parentheses. How far right does it go? To +infinity. Alright, if you see -infinity to +infinity, you should say all real numbers. Now, I'm also going to show you this third way. It's technically correct, so we can do that. So just like that problem on the left where I did the first number, then x, and the second number, I can do this too. I can say -infinity, x, +infinity, less than. Alright, so that's another way of writing that. So make sure you understand that. Again, if it's numbers, it makes more sense. Range, same idea, low to high. The lowest is -4, and it's closed. The highest is +infinity. So, or, we should write y, the only non-infinity number is -4. If it's first, that means it has to be greater than the first. So greater than, this is closed, but so greater than equal to the first, less than the second. If you want to do the other way, you could do this. You could write the first number, y, the second number, always have less than signs. And since the -4 is closed, put equal sign there. So all those are the same thing. But remember, if I tell you my number is less than infinity, that's redundant. That doesn't really help you. That's why we usually erase the other side. Alright, done enough time. I do. Alright, say where that point is a solution for each of the inequalities. You just plug in. So -3 for y, 4 for x. I'm going to simplify. This stays the same. 3 times 4 is 12 minus 10. This is -3. I combine. 12 minus 10 is 2. Is -3 bigger than 2? No, that's false. So it's not a solution here. So not a solution. It has to be true. I'm going to try it for the other one. I'm going to plug it in. So -3 less than or equal to 2. Absolute value 4 minus 7. Make sure you work on the inside first. So 4 minus 7 is -3. Absolute value of -3 comes out +3. I multiply that. 6 minus 5. I simplify. -3 less than or equal to 6 minus 5 is 1. That is true. True means it is a solution. Alright, so solution there. Not a solution here. I'll stop here and continue on the next part.